Okay, students, today we're going to do the quadratic formula. So here is the quadratic formula right here. You need to get this memorized. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, you need to say all over 2a. That means a long division bar. Okay, over everything I just said. If I just said negative b plus or minus the square root of b squared minus 4ac over 2a, then the over 2a would just be on this part only. Okay, it'd only be over the last part, not over the negative b. So that's why you say all over. Okay. All right. So first problem, solve using the quadratic formula. Well, why do we need the quadratic formula? We just got done solving by completing the square. No, we haven't done completing the square. That's next. At least in the order I'm doing it right now. We've only solved it by factoring, but that means they could factor. Well, not all quadratics factor. So when they don't factor and you don't know how to complete the square yet, you need to use quadratic formula. So quadratic formula works for all quadratics. Factor only works sometimes. Okay, but quadratic formula always works. That's why you need to know this and how to apply it correctly. And notice it's got a square into it, so you have to be able to simplify your radicals, which is what the first lesson of this unit was about, simplifying radicals. Okay, because you have to be able to do that with quadratic formula. Now, remember with quadratics, it's degree 2, which means there's 2 answers. And there you see your plus or minus. Negative b plus that root all over 2a, negative b minus that entire root all over 2a. There's how you get your 2 answers, okay? So remember, the degree of the polynomial tells me how many answers. Remember, I write it in standard form. It's standard form, ax squared plus bx plus c equals 0. We can only solve if there's an equal sign. There's my equal sign. First step in solving all quadratics, we know from factoring is to set equal to 0. Well, in this case, it's already set equal to 0. If it's not, then we'll have to do that. Okay, so remember, ax squared plus bx plus c. That's standard form. That's where these a, b's, and c's are coming from right here. The a, b, and c right there. So you can go ahead and write right underneath there a, b, and c, and you can even circle them so you make sure you include the sign with it. Okay, and then we're just filling it into the quadratic formula. And then notice it says round your answers to the nearest hundredth. So we're going to first find the exact answer, and then we're going to play in the calculator. I'll show you how to do that and round each answer, because notice the solutions, because there's even giving you a hint, there's 2. I mean, solution mean more than 1, but as I already told you, it's 2 because it's a quadratic. Degree 2 tells me 2 answers. So then we'll plug in both answers in the calculator, show you how to plug it in there, and then round to the nearest hundredth. Okay, so x equals, oh, and by the way, where is this, what's the point of the quadratic formula? Remember, we were doing graphing quadratics last unit. And when it was in factored form, we would have the x-intercepts, roots, zeros, or solutions. Well, when it doesn't factor nicely, it still could cross the x-axis like this. And so now, when we're using quadratic formula, we're finding that decimal answer, in this case, the nearest hundredth, where it crosses the x-axis. So those are called x-intercepts, roots, zeros, or solutions. Okay, so this is used for that again. Okay, you will use this in geometry a little bit. You'll use it a lot in algebra 2. Okay, and beyond. Discrete, pre-calc, you have to know it. Calc. Okay, you got to know this formula and be able to work it well. Okay, so let's go ahead and fill it in. X equals negative b. Another word for negative is the opposite. So what is the opposite of b? Right now, b is negative 6. So the opposite is plus 6. Plus or minus the square root of b squared. Negative 6 squared. Remember, when I substitute in, I put parentheses. Negative 6 squared, b squared, minus 4a is 3, and c is 2. All over 2 times a, and a is 3. Okay, so now we just start simplifying this. 6 plus or minus the square root. Negative 6 squared is 36. You will only get a positive answer there, because when you square any number, it has to be positive. So you better not ever have a negative written there. 4 times 3 is 12, times 2 is 24. So minus 24 all over 2 times 3 is 6. Okay, so now we have x equals, you gotta show me these steps. Can't be skipping. Using some math program on the computer, it might skip steps. You don't get credit for that. You gotta show me that you know how to do it. Fill it in quadratic formula. So I have 6 plus or minus the square root. 36 minus 24 is 12 over 6. Well, now I see I have to be able to reduce my radical. I should already know by now that square root of 12 equals 2 root 3. Square root of 4 times square root of 3 simplifies to 2 root 3 all over 6. And now I can see I have a GCF of 2 in the numerator. I can factor out a 2 from each term. I'm left with 3 plus or minus root 3 all over 6. And that 2 cancels that 6 3 times. So there's my two exact answers. 3 plus or minus the square root of 3 all over 3. Okay, there's my two answers. 3 plus root 3, get that answer, and then divide by 3. And 3 minus root 3, get that answer, and divide by 3. Okay, so now we're going to go ahead and plug in the calculator. It depends on how many steps I want to take. If I want to do it all in one step in the calculator, remember, I've told you this over and over, if I have more than one term in the numerator or denominator, I put parentheses around it. I have two terms there. Remember, terms are separated by plus or minus signs. So if I want to do the whole problem in the calculator at one time, I would need to put parentheses around that right there. You need to remember that. If you're not going to do it at one time, you could do the 3 plus root 3, get that answer, and then divide by 3. And the other one would be 3 minus root 3, get that answer, and then divide by 3. And then that would be your final approximate answer. Remember, that's the approximate symbol because you can't get exact, round to the nearest hundredth. Okay, but if I want to do it in one step, which I will do, I just showed you if you want to do it in 2 steps right there. I'll do it in 1 step on the calculator now. So we have parentheses 3 plus the square root of 3 parentheses divided by, oops, I have to hit the right arrow. So let's get back underneath here, delete that. I have to hit the right arrow to get outside of the parentheses. I got to get rid of that parentheses. Well, I need to get out of there first. Okay, get out of there. Now parentheses like that. So there's the whole numerator divided by 3. There's that answer. The other one was 3 minus that same thing, square root 3, right arrow, parentheses, divide by 3. Oops, I made an error somewhere. Let's see. Oh, I forgot my first parentheses. See what happens? I can go back here, hit second delete, which is insert, and put a parentheses there. That way I don't have to retype the whole thing. Okay, then hit enter. Okay, so those would be my 2 answers. Of course, this round to the nearest hundredth would be 0.42. Okay, let's say, oh, I forgot what my last one was. I can hit second memory, oops, not memory, second entry, we quit first, second entry again, second entry right there, 3 plus root 3, and hit enter right there, and there's my other one. See, if I do second entry, it keeps going back a step each time. Okay, and I went and found my 3 plus root 3 divided by 3. So this would be 1.58 because that 7 makes it round to an 8 right there. So there would be my 2 answers. Okay, I'm doing it in 1 step. Now remember I said you could just do 3 plus root 3, hit enter, and then divide by 3. And there's that answer right there. And I could do 3 minus root 3, get that answer, and divide by 3. And there's that answer. You can't see it now, but it was the same thing, 0.42. Okay, so I just showed you both ways on how you can do it on the calculator. Okay, let's go back and do one more problem. So notice here, again, if I ask what kind of equation is this, you look for the highest degree. The highest degree is a 2. So what do we call all degree 2 equations? Quadratics. So you tell me it's a quadratic equation. Then I ask you what's the first step to do with all quadratics? And you should be able to tell me step 1 is set equal to 0. We want our leading coefficient to be positive. Okay, so here's this quadratic term right there. Is that leading coefficient positive? 1? Yes, it is. So we're moving everything to the left side. So I've got to move that. Notice I put that there because that's where the like term is. Notice I put that to right there because that's where its like term is. Okay, so that's now gone. I get 0. So I have 1x squared minus 13x. This is just integers plus 22 equals 0. Okay, so remember that's always our first step with all quadratics, set equal to 0. We want our leading coefficient to be positive. It makes it much easier to work with. Okay, I could check to see does it factor, does anything multiply to 22 and add to 13? 2 and 11 do. Okay, so if we wanted first, for the heck of it, do it by factoring, I'd have x minus 11 and x minus 2. Okay, that gives me that right there. Set each one equal to 0. So x equals 11 or x equals 2. Okay, so that's what my answer should be now when I do the quadratic formula. Okay, I was able to, since I'm good at factoring, I could quickly factor that, get my two answers. So you notice that factoring is much quicker if you can factor. That's why you really want to learn how to factor well and quickly, because you saw how quick that was compared to now having to plug this whole thing in the quadratic formula. So if you don't know how to factor, you're now stuck having to use the quadratic formula all the time, which takes a lot longer and way more chances for errors. Okay, so I'm going to write it down first. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Start saying that over and over. Get it memorized. Okay, that's how you memorize it. You say it over and over. All right. Remember, I can go ahead and identify my A, B, and C right there to fill in. So x equals the opposite of b. The opposite of negative 13 is positive 13. Plus or minus the square root of 13 squared is 169. If you know your squares for extra credit, you'd already know that. Minus 4a and c. Okay, remember if you want, circle the numbers so you include the sign with it. So you make sure you have the right sign for each of those. All over 2a. 2 times 1 is 2. Okay, so now I have x equals 13 plus or minus the square root. That's 88. So that gives me 81. 169 minus 88 is 81. All over 2. And of course, everybody should know that the square root of 81 is 9. So now I have 13 plus 9 divided by 2, or 13 minus 9 divided by 2. What's 13 plus 9? 22 divided by 2, and that's 11. There's my 11 answer right there. What's 13 minus 9? 4 divided by 2, which equals 2. There's my 2 answer right there. Okay, so that's another way. For example, if you can factor, you could quickly have factored. I got the 2 answers. Okay, I know what I better come up with. I better come up with 11 and 2 when I do my quadratic formula, because there's going to be a problem that says you have to use the quadratic formula, because I want to test whether you can do the quadratic formula or not. Okay, but if you can factor as well, and that problem happens to factor nicely as well, you could quickly factor it and know what your 2 answers should come out to be. Okay, of course, just like any equation, I could take those 2 answers and plug it back into the original equation and check if I plugged them into all the x's here that both sides would be equal. Okay, so that's how you use the quadratic formula. Again, that is to find, the whole point of that is to find where the parabola, so we had 11 and 2. So 2 and 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 and 2. Okay, so the graph looks really sketchy, but it looks something like that. It has to go through 2 for the x-intercept and 11 for the x-intercept, also called roots, zeros, or solutions. And we know it opens up because that coefficient was positive 1, the leading coefficient. Remember, that's the shape of the graph, 1x squared. Remember, ax squared is the shape of the graph. So that graph would be a regular x squared graph. Okay. Remember, for quick review, if I wanted to know where the um, axis of symmetry is, also called the line of reflection, remember that equation is x equals negative b over 2a. So negative b would be 13 over 2 times 1 is 2. So that is 6.5. Okay, now I could have used that, or remember, since I have the intercepts, 2 and 11, I know it's halfway in between there. So how far is from 2 to 11? 2 to 11 is 9. Now I got to divide by 2, and that's 4.5. So I can add 4.5 to 2. 1, 2, 3, 4.5. So that's going to be 6.5. Okay, so x equals 6.5, just like I got with the negative b over 2a, because I have it factored right there. So this is a quick review. Okay, then if I wanted the y coordinate, I'd have to plug in that 6.5 into the equation. Now, what's easiest to plug in, just for doing it in your head, is actually to plug it into this factored form right here. Then to plug it into this entire top equation, all that's a lot more work. I could just plug it into this factored form right here. So if I plugged in 6.5 there and 6.5 there, 6.5 minus 11 is negative 4.5. And 6.5 minus 2 is positive 4.5. Okay, well, now let me show you another shortcut on how to multiply those two numbers. We know negative times a positive is negative. Whenever I have any number that ends in 5 squared, which this is 4.5 squared, it's going to always end in 25. And I take the number next to it, in this case 4, and times by one more than 4. 4 times 5 is 20. So it's 20, 25. And then since I have one decimal times another one decimal is 2 decimal, I move 2 decimal places to the left. So that answer is negative 20.25. Look how quick that was and easy that was compared to if I would have had to plug it in a calculator and plug it all into the equation itself right there. I'll try to do it by my hand in the head right there. So going back to here, this would be at this point would be 6.5 comma negative 20.25. Okay, is where that vertex would be. And of course, it's a minimum because it's the minimum y value. Remember, minimums always deal with the y value. So we got the axis symmetry, x equals 6.5. Remember, it's always an equation. X equals is a vertical line, so it's x equals. Okay, and we can do a quick, nice sketch of it right there, going through the x-intercepts, roots, zeros, or solutions. All right, we'll go ahead and end right there. Quick review of the quadratic section also.